This is a question from February-March 2017, question 3. Nitrile chloride reacts with nitric oxide. The forward reaction is exothermic. The reaction can reach equilibrium. Question A. What is meant by the term equilibrium for a reversible reaction? Now, for the definition, you could simply just refer to the notes. Over here in chapter 6, I have uploaded the definition of equilibrium. It says that the forward reaction and the backward reaction occurring at equal rates. This gives you 1 mark, and the other mark is obtained from the second point, whereby you can either say moles, mole, or concentration of the substances remain constant at all time. Question B. Explain why increasing the temperature increases the rate of reaction. Now this is speaking of the rate of reaction. Rate of reaction is usually due to the effectiveness of collision between the particles that is in your molecule. Now this chapter would be explained in further details in your next video, so I'm just going to read out the answer. It says that particle gain more kinetic energy and it moves faster. So this gets a higher rate of collision, and more collisions means you get a higher rate of effective collision. I'll be explaining further about the factors that affect rate of reaction in our next chapter. So question C is regarding equilibrium. It says that state and explain the effect, if any, of increasing the temperature of the position of equilibrium. When it comes to temperature, the first thing that you need to look is whether the forward reaction is exothermic or endothermic. Now if you look back at the factors affecting the position of the equilibrium, the first thing that you have determined is that this forward reaction is exothermic. If the forward reaction is exothermic and you increase the temperature, our reactants will increase and the products will decrease. So if our reactant is increasing, this means that our equilibrium would shift to the left, causing our yield to decrease. However, this is a 2 marks question, so you also have to give a reason why it moved towards the left. Now the next question is asking you to state and explain the effect, if any, of decreasing the pressure on the position of equilibrium. Now when it comes to pressure, you don't have to determine whether it is exothermic or endothermic. What you need to know is the number of moles for each of the molecule that is present in this reaction. For example, you have 1 nitrile chloride here and 1 nitrogen oxide here. That means on your reactant, you have the number of mole of 2. Looking at your product, you have 1 nitrogen dioxide and 1 nitrosyl chloride, giving you also 2 moles for your product. So you have an equal number of mole on your reactant and your product. The effect on pressure change for the equilibrium is different with temperature. When you increase the pressure, the equilibrium will shift into the direction where there is a smaller number of moles. So for example, as you can see here, the product has 2 moles, whereas the reactant has a total of 4 moles. So if you increase the pressure, it will move to the side with a lesser number of mole. That means your equilibrium in this example will move towards the right, which is towards the yield. Now for the question given here, we can see that it has an equal number of mole at the reactant and at the product. This means that there will not be any effect towards the equilibrium when you increase or decrease the pressure. So you could say that there will be no change on the equilibrium, and since there are 2 marks, you need to give a reason why. So the reason is that the number of gases on each side is equal, and that is why there is no changes. This is a question from October-November 2017, question 5. B is asking you to deduce the volume of hydrogen, so we are going to skip that question for this chapter. Now moving on to question 2. If the pressure is increased, the yield of hydrogen becomes less than 70%. Explain why in terms of the position of equilibrium. Now this is exactly similar with the question that we did just now. The first thing that you need to do when it comes to the factor of pressure is to determine the number of moles for the reactants and the product. So as you can see here, there are a total of 2 moles for our reactant and there are a total of 4 moles for our product. When the pressure is being increased, the equilibrium will move to the side which has a lower number of volume. So in this case, your equilibrium will shift towards the reactant. If it shifts towards the reactant, this means that your yield will decrease. So it does apply to this statement where it says that your yield become less than 70%. So how you explain is just by using the number of moles to get your marks. Just say that there are fewer molecules on the reactant side and you can get 1 complete mark. Next question is saying that if the temperature is decreased, the yield of hydrogen also decreases. What does this information indicate about the reaction between methane and steam? Now in the previous question, what they mentioned was that the forward reaction was exothermic or endothermic. However, in this question, it is a little bit reversed because they are not telling you what the forward reaction is. Instead, they are telling you that when they decrease the temperature, your yield is decreasing. So now let's refer to our table. I've only put a column for increasing temperature, so automatically when you decrease the temperature, the opposite happens. So when you decrease the temperature, for exothermic, your product will decrease and for endothermic, your product will increase. So the question has mentioned saying that the yield decreases. If the yield decreases, this means that your forward reaction is exothermic. Now this question is regarding the rate of reaction and what is a catalyst used in this reaction. Catalyst is a substance that speeds up a chemical reaction without changing the amount of its substance itself. So if they ask you why, you could just simply say that it increases the rate of reaction. This is the question from February-March 2019, question 4. This question is about ethanoic acid. A. Ethanoic acid is manufactured from methanol and carbon monoxide. This process is done at 200 degrees Celsius and 30 atmosphere pressure. The forward reaction is exothermic. Now take note of this information here. Complete the table using the only word increases, decreases, or no change. So on this column, you want to know the effect on the rate of forward reaction. And on this column, you're looking at the effect on the equilibrium yield of ethanoic acid. So let's do the one for the forward reaction first. If you add a catalyst acts in a way that speeds up the reaction. So of course, your forward reaction over here would increase. Next, increasing the temperature. If you increase the temperature, that would be more kinetic energy, therefore your forward reaction would also increase. However, for the equilibrium, it's different. For equilibrium, you need to determine what is your forward reaction like. Your forward reaction is exothermic. So if your forward reaction is exothermic, when you increase the temperature, your product would decrease. This means that your yield, the product, is going to decrease. Now the last one is about decreasing the pressure. So when it comes to pressure, you need to look at the number of moles. You can see that there are 2 for your reactant and only 1 for your product. If you increase the pressure, it will move to the side with less reactant, which is your yield. But if you decrease the pressure, it would be the opposite. It would go to the side with the more number of volume, which is your reactant. So now that you're decreasing the pressure, your equilibrium would start to move to the side which has more reactants. If it goes towards reactant, this means that your yield would decrease. This is the May-June 2019 question 4. Methanol is made industrially by reacting carbon monoxide with hydrogen. The gases react at a temperature of 250 degrees Celsius and a pressure of 75. Again, pay attention to what the forward reaction is, and over here it is exothermic. So question B says that you need to complete the table using the word increase, decrease, or no change. Exactly similar with the one that we did before. Now if you add a catalyst, it will speed up your reaction. If it speeds up your reaction, this means the effect on the rate of reaction would increase. And if you decrease the pressure, that means the rate of reaction would decrease. Now that you're done for the side of column for rate of reaction, we'll move on to the effect on equilibrium. So when you increase the temperature, you need to first check what is your forward reaction. Since it is exothermic, when you increase the temperature, your product would decrease and your reactant would increase. So since they want the product here, you need to mention that it would decrease. And if you decrease the pressure, so pressure depends on the number of mole. You have 3 reactants and 1 product. If you increase the pressure, it would go to the side of a lesser volume, which is the yield. But if you decrease the pressure, it would be the opposite. It will go to the side with the more volume, which is your reactant. So now that the case is decreasing the pressure, your equilibrium will move to this side, causing your yield to decrease. Reactant increase. So the answer to this part would be decreases. This is a question from the specimen paper 2020. Question 7. Iodine reacts with chlorine to form dark brown iodine monochloride. And this reacts with more chlorine to give yellow iodine trichloride. An equilibrium forms between these iodine chlorides. So we have dark brown on our reactant and yellow on our product. Question A. What do you understand by the term equilibrium? So this question is asking you about the definition of equilibrium. So please memorize this as it will give you a complete 2 marks. Forward and backward reaction occur at equal rate gives you 1 mark. And the next point you get from this sentence saying that the concentration of substances remains unchanged. Question B. It says then when the equilibrium mixture is heated, it becomes a darker brown color. A darker brown color means this one. That means your reactant has increased. It suggests if the reverse reaction is endothermic or exothermic. So now that you know your reactant has increased, what you need to do is determine whether it is endo or exo for reverse reaction, not forward reaction. So let's look at our table. If your reactant is increased, it would be exothermic. For your forward reaction, that means your backward reaction is endothermic. So your answer is that endothermic for reverse reaction because the direction is favored by high temperature. Please note that you have to give the reason why even though the question only gives you 1 mark because it already mentioned here that you have to give a reason for your choice. So question C, the pressure on the equilibrium mixture is decreased. How would this affect the position of equilibrium and give a reason for your choice? So now that we're talking about pressure, we need to look at the volume of molecules. So if you look here, you would see that you have got iodine molecules here and chlorine molecules over here for your reactants. However, for your iodine chloride, you only have 1 molecule of iodine chloride here. This means that your reactant has more moles compared to your product. So if you decrease the pressure, it will move to the side of more molecules, which is your reactant. So the reason is that it would move to the left because there are more molecules at the reactant. Describe what you would observe. Observe is what you can see. Since this question has already given you the hint of color, saying that dark brown is on the reactant and yellow is on the product, this is the information that you have to use for observation. Since your reactant is increasing, that means you would see a darker brown color. So you can say more dark brown. This is the question from October-November 2017, question 5. It says that some chemical reactions are reversible. Question A, aqueous potassium chromate is yellow solution. Aqueous potassium dichromate is an orange solution. So they have given you here the chemical reaction. Yellow is on your reactant and orange is on your product. Says that solution Y is a mixture of aqueous potassium chromate and aqueous potassium dichromate at equilibrium. The first part is asking you to explain the position of the equilibrium, what you would see if sulfuric acid were added to solution Y. Now solution Y is this solution of chromate and dichromate. So sulfuric acid, now sulfuric acid is H2SO4. So this means that you are adding an acid solution into your mixture. So you have to determine right now, adding a solution into your mixture would be which factor? It wouldn't be pressure because you're not changing the pressure. It wouldn't be temperature as well, but it could be and it should be the concentration, because you are adding a different solution into the mixture, and now you would have more molecules present inside of your mixture. So as you can see here, if you're increasing the concentration of reactants, your equilibrium will shift to the right side, which is the yield. So if you increase this, your product will also increase. So your equilibrium will shift to the right hand side. However, this question is asking you what you would see. So on your right hand side, you can see that there would be orange color solution. So this would be the observation. More orange is seen, and the reason is because your concentration has been increased. Now the next question is asking you to explain in terms of the position of equilibrium what you would see if sodium hydroxide were added to the solution. Why? Now, as you can see previously, we have added sulfuric acid. So sodium hydroxide has a base property. If you add sodium hydroxide to a solution which contains sulfuric acid, it would neutralize the solution. This means that your equilibrium would start to move on the opposite direction now. Previously it was going to the right hand side. Now that you have neutralized it, it would start moving to your left side. So after you have mentioned left side, they're also asking what you would see. So what you would see is a higher concentration of yellow color. However, this question is 5 marks, so please give a reason for both your statement. This one was due to the higher concentration added into your mixture. And for the second part is due to the neutralization of sodium hydroxide and sulfuric acid. This is the question from May-June 2017, question 5. So part C is not related to this chapter, and this is the second part of the chapter where you have to calculate the overall energy change for a reaction. So now let's look at the question. It says that iodine reacts with chlorine. Use the bond energies to answer the questions. So for this type of question, usually they will already give you the value for the bond energy for each bond that is present in this reaction. So for example, the first one you have I2. I2 means the iodine is bonded in a way whereby you have two iodine atoms attached to each other with a single bond. And this single bond value is 151 kilojoule per mole. Same goes to chlorine. You have got two chlorine atoms which is bonded by a single bond, and the value of this bond is 242. And as for iodine chloride, you can see here iodine and chlorine is bonded together by a single bond as well, and the value is 208. However, if you look at the equation, there is number 2 in front of iodine chloride. That means that we have got two bonds that are present in your reaction. So let's look at the first part of the question. They're asking you to calculate the total amount of energy required to break the bonds in 1 mole of iodine and chlorine. So the energy needed to break the bond is what happens in your reactants. So as you can see here, iodine needs to be added up with chlorine. So the bond for iodine would be 151 kilojoule per mole. There is only 1 mole of iodine, so I'm not going to multiply any number by it. And I will add it up with the Cl-Cl bond, which is the chlorine bond, and there's only one, so it is just 242. So the total amount of energy required to break the bond mean you have to sum up I2 with Cl2, giving you a value of 393 kilojoule per mole. Now the next part is asking you to calculate the total amount of energy given out when the bonds in 2 moles of iodine chloride are formed. Now in this table they only give you the bond energy for 1 mole of iodine chloride, which is 208. As you can see in the equation here, we have got 2 moles of iodine chloride. This means that you need to multiply the bond energy for chlorine by 2. So this will give you a value of 416 kilojoule per mole. Now the last part is asking you to calculate the overall energy change for the reaction. In order to calculate the overall energy change for the reaction, the energy to break bond need to be minus with the energy to form bond. So to break bond, you've got 393. This means that this value has to be minus with the energy to form, which is 416 kilojoule per mole. So your overall energy would be negative 23 kilojoule per mole. Now your answer would be in negative, and don't worry, that is still right. And negative or positive just determines whether this reaction is exothermic or endothermic. If it is negative, it is exo. If it is positive, it is endothermic. This is a question from October-November 2017, question 3. C. The chemical equation for the complete combustion of methanol is shown. So as you can see here, they have broken down the bonds for each of these molecule given. They want you to find the energy change for the complete combustion. This table has given you the bond energy for each bond present in your reaction. First part is asking you to find the energy needed to break the bonds. So in order to break the bond, it means that you need to find the total energy here in your reactants. Before we calculate, let's determine what bonds are present in each of your compound. So as you can see here, you have got 1, 2, 3 CH bonds. You have 1 CO bond. And you have got another 1 OH bond. However, there is a number 2 in front of here. This means that you need to multiply everything by 2. So this would be for methanol, and then you have to add up with 3 oxygens. So oxygen has a double bond. This means that you have got 500 over here. There's only one double bond of oxygen present here. However, there are 3 molecules of oxygen, meaning that you have to multiply this by 3. So this would be for your oxygen. If you add up everything, you would be able to get an energy of 5,600 kilojoule per mole. Now the next part is asking you to calculate the energy released when the bonds are formed. So for the bonds formed, you need to look at your products. So as you can see here, you have got 1 and 2 double CO bond. So you have to multiply this by 2. And then you have got 2 OH bond. So you need to multiply this by 2 as well. But do not forget to look at the total number of moles. You have got 2 double bond of CO, so this one has to be multiplied by 2. And you have got 4 of these molecules, so you have to multiply this by 4. So if you sum up the energy released from each bond and the number of moles, you will be able to get an answer of 6,900 kilojoule per mole. So the last part is asking you to calculate the energy change. So similar with the question that we did before, you have to minus the energy needed to break the bonds with the energy released when the bonds are formed. So this would give you a value of negative 1,300 kilojoule per mole. Again, if you see the negative symbol, your answer is still right. It just means that this reaction is an exothermic reaction. So this is the question from February-March 2018. I have solved it as this is just a repetition of the same pattern of question. You can see here that we have got 3 bonds of NH, so I've multiplied it by 3, and 2 molecules, hence there are 2 here. And then you have got 3 molecules of 1 single bond of chlorine, so 3 multiplied by 1. If you add them together, you would get 3,060 kilojoule. As for the part of energy release, you need to look at your reactants. You have got 1 triple bond of nitrogen, and you have got 6 molecule of 1 single bond hydrogen chloride. So 1 multiplied by 6, adding up with 1 single bond of nitrogen, this would give you a value of 3,525. For the energy change, you need to minus 3,060, which is your energy needed to break the bond, together with the energy released to form the bond. This would give you a value of negative 465. So is the reaction endo or exo? It would be exo since your energy change is a negative. So this is the specimen paper of 2020, question 7. This would be one last question that I discussed for the overall energy change. as I believe that you already know how to calculate this based on the multiple examples that we have done. So D says to calculate the overall energy change for the reaction between iodine and chlorine using the bond energy shows. So for iodine, there's only one bond, so you multiply it with 1. For chlorine, this means that you only have one single bond of chlorine, multiply this by 1 as well. Iodine chloride means the single bond would look like this, but you have 2 over here, so you multiply it by 2. So the first step would be to find the energy change for bond needed to form, which is in your reactants. So this would give you a value of 393 kilojoule per mole. And the second step would be to find the energy needed when the bonds are being formed, which is in your product, giving you a value of 416 kilojoule per mole. So in order to find your overall energy, you need to minus them. This would give you a value of negative 23 kilojoule per mole. Now the reason why I tried this similar question is because part E is asking you to draw a labeled energy level diagram for the reaction between iodine and chlorine using this information. So as you can see here, since this gives you a negative value, it shows you that this reaction is an exothermic reaction. For an exothermic reaction, your energy level diagram would look like this. Your reactant would have a higher energy compared to your product, giving you a negative value for the overall energy. So once you have completed the diagram that looks like this, please do not forget to label the necessary information. For example, this axis would be your energy. So this is how your labeled energy level diagram would look like.